Today we're going to be going over 3.1 over functions and domain. For this unit, we're going to be talking about first the definition of the function and then going into domain on various functions. So a function is something that has one output for each input. Sorry guys, I keep failing. All right, so our output is going to be usually called our y value, and our input is normally called our x value. So what this represents is that, let's say our input is a time. If time is our x value, or our independent variable, you can't have two different distances or two different amounts with the same amount of time. So that's why we're talking about functions. They have more application to real life instances. If we take a table like this one down here, for this table, we're looking, for all of our inputs, all of our x values, -2, 0, 1, 3, 5, and 3. We can see that our 3's do repeat. Now, for your assignments, anytime that they repeat, it's not going to be a function. But in general, especially as you go on to other math courses, you always have to look to see what about their outputs. You can see the outputs are 1 and -2. Those are not the same value, so therefore this would be not a function. Occasionally, as you get into other coursework, you'll have 3, 1, and then that same point or ordered pair may repeat as a 3, 1. And then in that case, you would still have a function. But this one is not, because there are two different outputs for the same input or x value. Now we're going to switch over to domain. I have a couple different graphs up here that are going to be a good overview of all the different types of functions that you'll see in this course. If we look at our first linear graph over here, for domain is going to be where you live. It's your territory. So domain is always going to go from left to right. So I'm going to say left and make that into an arrow to right. It's always going to be represented by our x values. And you can write domain in interval notation, which means with parentheses and brackets, and that's what we're going to be doing. You can also do in something called inequality notation with like less than or greater than signs. But for us, we're just going to use inequality or interval notation. So if we look from the left side to the right side, we go from an arrow to an arrow. So our domain for this question, for those x values, going from left to right, where I hit arrow, and this line continues forever. So arrow, our domain is -infinity to infinity. Another way we can say that is all real numbers. So these two things mean the exact same thing. They mean we're going from forever to the left to forever on the right. All real numbers is a word format that means -infinity to infinity. There's even a mathematical symbol that represents all real numbers. For our next type of function, this is called a rational function. And if we looked at our equation itself, we could see if we plugged in a -2 right here, that the entire bottom would be 0. And that's a big no-no in math. You can't do 1 divided by 0 or anything divided by 0. It just doesn't work, which is why my graph does this strange little curve, as you can see. So, I did forget a negative. I'm very sorry. And so for this graph, if we're looking at the domain from left to right, our domain, which I'm going to abbreviate with a D, from left to right, has a break in it. It is not all real numbers. So from the left, we hit an arrow first. That means -infinity. But then I go to this vertical line, or where the graph kind of seems to get confused or just go upwards forever. And so at -2, there's a break. And the reason for that break, remember, is because if I plug in -2, my function's not defined. I can't find out what the value is. But then we jump all the way back down here, and so it starts again at -2, and then it goes all the way till we hit an arrow. So we're on this left side arrow all the way till -2, then I jump down, -2 all the way to this arrow. And remember, arrows mean infinity, and we use parentheses for those. Well, you can't just write these two things in math. We must include a symbol to unite them. So this is a U, and it means union. It means we're on one side of the graph, and we're going to combine that with the other side. A life application could be whenever you get married. You have your stuff and their stuff. When it's a marriage union, it's now jointly together our stuff. And that's what that U represents. Last but not least, we do have a square root function. This is not a typical one. You can see it's 3 minus x. So if I plug in a 3 right here, you can see that it would hit that 0 mark. That's where my x-intercept comes from. And if it was something larger like a 4, we can't take the square root of it. So this function is only defined until positive 3. So for the domain on this function, I'll flip to this way so you can see me. We're going to start at negative infinity. And we go all the way till we hit the 3, where it's a solid dot or part of the graph. So for us on this one, it goes negative infinity to positive 3. And we're going to put a bracket. A bracket's going to have those squared off edges, and that represents that it's equal or part of that graph. We have another topic to cover, and that's going to be our function notation. So for function notation, I'll jump to this side. They give you a function where it's f of x. So what this means is that wherever the x is, we're going to be replacing that with whatever is inside of these parentheses, like this 2 right here, or this negative 1, or this letter p. It's going to be replacing where the green is on those equations up top. So I'm going to try to double code or color this for us. So for f of 2, we're going to have 4 times 2 squared plus 2 times that. So if I plug in my 2's, a 2 and a 2. Remember, because my 2 is inside the parentheses, that's what's representing my x value. So the 2 spots where there's an x, I'm plugging in my number. So here it's going to become, I'll switch to a different color for you. 4 times 4 plus 4. Oh my goodness, so many 4s. Well, this is going to be 16 plus 4 to get to our final answer of 20. For our next part, we're going to plug in a negative 1. If you are using a calculator, this one's going to be very important to make sure you use these parentheses and don't just do the multiplication symbol. So when I plug in a negative 1 for each of these, a negative 1 squared is like a negative times a negative, which equals a positive value. So if I use yellow again, we're going to get 4 times positive 1. Oops. And then 2 times negative 1 turns into negative 2. So you can see our answer here is just positive 2. Because 4 minus 2 is just 2. Let me move up my board a little bit. I'll actually shrink it down so you can see all the things. So for this one, we're going to do the same thing. We have 4. We're going to plug in our letter this time. Well, when I plug in my P for my letter, we can't really reduce it at all in yellow. So in yellow, what our new equation is going to be is just 4p squared plus 2p. There's nothing else to do. These are unlike terms. Something with a letter that's squared and a plain letter, you cannot combine them together. So that one is finished. The reason we had to cover function notation like that is because of our difference quotient. So I know, oops, sorry, I was trying to see if I can get the glare off there. So you can see for that difference quotient, it's going to be f of x plus h minus f of x all over a plane h. So what that means is that we have to plug in the x plus h, the x and the h, into our normal function. So if we do that, we're going to have, we're going to replace that x, that is 4, minus, and I'm going to put it in a big parentheses. This extra little minus right here can sometimes trip up people up. So I'm going to have, this is my big f of x plus h. It's going to be my big f of x. and this was just x squared minus 4, it doesn't change, and the bottom is just an h. So what I have to do on the top here, this is going to turn into x plus h, and we do have to square it. That means that we're going to be having to use, or we're going to have to be multiplying those together, which is called FOILing or multiplying two binomials. So we're going to take a moment and we're just going to write it up here. So x plus h squared. How do we do that? Well, that's the same as x plus h times x plus h. And to multiply these together, we are going to take our first x and multiply by both things. We're going to end up with x squared plus x times h. Then we're going to take this h times both things, plus, and you can switch things whenever you're multiplying. So h times x is the same as x times h. They can be flip-flopped. H times h is h squared. Well, once you're here, you can see that these two will combine together. So our final answer is x squared plus 2xh plus h squared. So why is that helpful at all? Well, if we're going back to our original equation over here, I can now replace this x plus h squared with our stuff in purple. So we're going to write all of that purple down. X squared plus 2xh plus h squared. The minus 4 still stays there. But this time I'm going to distribute this negative. I'm going to bring it to both things. Remember, this is like a negative 1. So a negative 1 times x squared is just minus x squared. And negative 1 times negative 4, so a negative times a negative turns that positive, plus 4. So, all over our h. Well, now if we think about combining our like terms, let's go that high, then we can see that this x squared minus this x squared can actually cancel out. And this minus 4 plus 4 will cancel out as well. So now what do I have? Now I have 2xh plus h squared all over h. I know some of you kind of see that and you think you're just going to cancel these, but there's a little bit more. I'm going to show you the true mathy way. I'm sure that you can come up with other shortcuts to do. So if I were to factor out an h from both of these, I now have 2x plus h. And the bottom stays the same. And now these cancel. So our actual answer is 2x plus h. Whew, that was a lot. So I'm going to zoom back out so you can see all those steps that it took to get there all at once. I will say a question this difficult will not show up in your college algebra or math business or any of those type of courses on any assignment or test, or sorry, on any test. So it might be on an assignment. This is more of a Calculus 1 kind of introductional question or sometimes a late pre-cal question. And that's all for this video.